Hello guys, warmly welcome to the chemistry pool, and today topic is modules of chemical bonding. For chemical bonding, we know that in chemistry these bonds are formed between what elements, right? Then what happened? Basically three types of bonds will form between these elements. First one is, I put A, metals and non-metals. Which type of bonds between metals and nonmetals? Metals and nonmetals, ionic bonds. That means what happened in here? Metals, basically metals here. Example as lithium. It has lower ionization energy. What? Lower ionization energy. I put it as IE. Then therefore it can easily lose the electrons like this. Then for non-metal, what happened? It has highest ionization energy there, but as well as highest electronegativity. Then what happened? It can gain the electrons. As example, chlorine, it can gain electron and get to chloride. Therefore, these two combine each other and form lithium, and chlorine combine each other. Lithium plus and chloride combine each other. Lithium chloride, these are ionic bonds, right? Both are got the noble gas configuration, this one and this one also, right? Then what about if part B, non-metals combine with non-metals? Then what happens? It forms what? Covalent bond. Covalent bonds. Covalent bonds with means electrons shared between two atoms. Basically it can't tell equally shared, but if the electronegativity difference equal, then what happen? Generally electronegativity denote from X, right? Here X A equal XB. Then what happened? These bond pair equally shared between these two atoms. If XA higher than XB, that means this bond electron pair not shared between equally, that it bias to atom A. These bonds are non-polar and this one is polar, right? Then third one is what happened if metal combine with another metal. Then what happened? That's metallic bonds, right? We know that there are electron pool like this and cations. Example, sodium plus for sodium metal, zinc through these electrons, right? It's easy. This is the little bit introduction for this topic, and then I am going to move the next topic, that is covalent bonds, right? Then covalent bonds means what happened in the covalent bonds? Electrons shared between two atoms in the molecule. Then these covalent bonds can describe by using three ways. First one is Lewis theory, right? Then second one is VBT. VBT means what? Valence bond theory. And third one is MOT, that means molecular orbital theory, right? Basically, from this topic, I am going to discuss about the Lewis theory. Then, for Lewis theory, we need to know that one major uh, definition, that is valence. Before I move to the Lewis theory, I need to explain new term, valence. Right? A valence means the number of electrons provided by an element to form a new bond. Right? Here I explain this one as a little bit example. I get A and B. This A and B make one single bond between those two elements and get the octane. That means 8 electrons around the both atoms. Right here you can see this octane occupied by using also bond pair, that this bond pair. Then for this bond pair, how many electrons? I put electrons like this one. How many electrons provided from the A is, here you can see 1 electron. Therefore, A provide 1 electron and B provide also 1 electron. Therefore, the valence is equal 1 for A and also 1 for B. Right? That's the major theory. Then, as the valence, I am going to another few examples. Here element and here electron configuration and here valence. Right? I get hydrogen. Now you know 1s1 electron configuration. Therefore, here is 1 electron and valence is 1. Why? Hydrogen can't get the octane, but it saturates with 2 electrons. Because of it, it's only remaining 1s orbitals, and in a main energy level n equal 1. Therefore, it can get 2 electrons, maximum number of electrons 2. Then what about helium? It contains 2 electrons, 1s 2. Right? Then you can ask the question, what is the valence for helium? Here you can see no need any electrons to provide mega bonds. Therefore, what? 0. Then for lithium, here you know electron configuration 1s2, 2s1. Then what means here from which orbital this lithium provide the electrons? That means outermost energy level. Outermost energy level means the energy level situated from more beyond from the nucleus. Then here n equal 2, and for outermost energy level you can see only 1 electron. Therefore, it can use 1 electron to get the octane, right? By losing 1 electron, it can go noble gas electron configuration. That means this electron configuration, lithium can write here something like this, right? 2s1. Here, now what happened? If lithium loses this 2s1 electron, it goes to noble gas electron configuration. Therefore, valence is 1. Then, how about beryllium? Here 2 electrons, 2s2 configuration for valence shell. Then, what what is the valence? Valence is 2. Then for boron here 3 electrons, that means 2s2, 2p1. What about the valence? You can see here boron can share these 3 electrons and form 3 bonds, but it's not get the octane, therefore it acts as electron what electron Lewis acid from the electrons, therefore valence is 3. Here for carbon you can see 2s2, 2p2. Then what about by losing these 4 electrons it can get the noble gas configuration O, right? Yeah, so what about here 4? Then for nitrogen 2s2, 2p3, then something like this. Then what about it needs another 3 electrons to get obtained 8 electrons, therefore it gives 3 electrons. When it provide 3 electrons to bond, other element also provide 3 electrons, therefore it can get the octane. Then what about the valence here? 3, valence is 3. Then for oxygen here it needs another 2s2, 2p4, another 2 electrons to get obtained, therefore valence is 2. Then for fluorine here 2s2, 2p5, therefore it needs another 1 electron to get obtained, that means valence is 1. Or otherwise fluorine shared 1 electron when it forms bond with other element, therefore its valence is 1, right? By looking this table, I put this one is table 1.1, different what valence of some elements, right? Then I'm going to explain some molecules. Example 1 is hydrogen by looking this table. Now here I can draw these 2 hydrogen atoms. I know here one hydrogen contain 1 electron, another one contain this electron. When you put the dot mark for one element, then you need to put the cross mark for conjugated one, right? Then what happened? Here this electron, this one and this one shared between each other. Then what happened? Forms H2. If you write this diagram, this is Lewis dot structure. To write this one as like this, right? This one is wrong because of when I draw the line between these 2 electrons, then this dot for hydrogen and X for this hydrogen, but it not equally shared between these 2 atoms, right? Then for Lewis dash structure, what happened here? Hydrogen, here another hydrogen, something like this. It's very easy, right? Then again I moved to another example, dinitrogen, example 2, N2. Now you know electron configuration of nitrogen, 1s2, 2s2 and 2p3. Therefore each nitrogen atom contain what? 5 electrons in the valence shell, something like this. And another one contain also, I put cross marks, something like this. Then what happened? These electrons shared between each other and then formed what? Triple bond, like this, right? Now you can see here For one nitrogen atom, it shared 3 electrons. 1, 2, 3. Therefore, valence is 3. For another nitrogen atom, it shared 1, 2, 3 cross marks. That means valence is 3. But when consider for each one atom with bond pairs, something like this, no? It shared between equally. Then for I put N1 and N2 here. For N1, how many electrons in around the N1? 1, 2, 3, 4, 5, 6, 7, 8. Right? Here 8 electrons. And for N2, also it has 8 electrons. Right? Now you can get the idea about how these bonds form and fulfill the electrons. Right? Example number 3, water molecule. Little bit complicated one. Then what about the valence of hydrogen? 1. Valence of oxygen is 2. That means oxygen share 2 electrons, hydrogen share 1 electron. Right? It's easy when I draw these molecules. This one. Right? What happened? For hydrogen, 1 dot. For oxygen, there are 6. 1, 2, 3, 4, 5, 6. And another dot for hydrogen. Now you can see oxygen shared only 1 electron per hydrogen, right? Then therefore it forms bond like this. Here hydrogen, oxygen, something like this, right? Okay, right? This is the what? Lewis dot structure. Right, it's easy when consider the hydrogen, but it has 2 electrons fulfilled. For this hydrogen, also 2 electrons. For oxygen, right, you can see for oxygen contain 1, 2, 3, 4, 5, 6, 7, 8 electrons. That means what? Octet. Right, maximum number of electrons equal to 8. That means the octet, right? I think now you can get some idea about how to draw Lewis dot structures and dash structures. Then we move to the little bit complicated ones. That means when we going to draw Lewis structure, like for atoms, molecules contain more than 3 or 5 atoms, something like this, nitrate, phosphate, then it's little bit complicated and we need to have some kind of steps. Therefore, we move to the another some different theory drawing of Lewis structure. Right? Let's move to the other video.